In previous lessons, I've already mentioned how important it is in Python to be aware of your indentation. So we know that when we create a function like this, that every line that comes after this definition that is indented is going to be inside this function. So by indented, I mean it's shifted to the right by 4 spaces, like this. So if you imagine each dot as a space, then this is a single block of code. And if we want to continue adding to this block of code inside my function, then we would continue adding lines of code which are indented. So you have to almost visualize for yourself this invisible line around these blocks of code which are indented. Now, if my code was written like this, on the other hand, then the block of code is in fact only this part. And this print statement will not get triggered when this function gets triggered because it's independent from this function because it's not indented. Now, a simple way I like to think about this kind of indentation is kind of like the file structure you see when you go into Finder on the Mac or when you go into Explorer on Windows. If we have a function, it's kind of like a folder, and anything that goes inside the function, for example, if I throw this file inside the function, then you notice that it gets indented, right? And this way it shows to you very, very clearly that these two files, print hello and print world, are living inside this folder, my function. And this is the equivalent of this code. We have this folder, say my function, and it contains these 2 lines of code. Now, on the other hand, if I take this print world and I put it outside of the function folder, then you can see that this is completely independent from that folder, and it's now indented at the same level as the function. So this is the equivalent of this code, where we've got this print hello being inside the my function and this print world being outside and at the same indentation level as this function definition. Now the indentation gets a little bit more complicated when we have other blocks of code. So for example, the if, elif, else statements, they have blocks of code which need to be indented to be inside the block. For loops need to be indented to be inside the loop. And it's very important that you get used to looking at blocks of code like this. So for example, if we were to expand our simple my function and add a whole bunch of code into it, then we would have to indent all of those lines of code by 4 spaces, represented by the 4 dots here. Now, if we wanted to have another block of code inside this if statement, then this line has to be indented a further 4 spaces. So this is the function block, this is the if block, this is the elif block, and you have to be able to see all of this while just looking at the indentation. If we wanted to represent this, then it's almost like creating a new folder. Let's call it the if sky is equal to clear. And this if block goes inside my function, so it's indented. Now, if I wanted to have a print statement, let's call it print blue, inside this if statement, so this is what should be executed if this function gets called and if the sky is equal to clear, well then this line is indented twice. And that is the equivalent of 4 spaces in our code, like this. Now, every time I've talked about indentation, I've been talking about spaces. And actually, there's 2 ways of creating indentation. You don't have to just use spaces. You can also use tabs, and that's created using the tab key on your keyboard, which can look a little bit like this. Now, there's a lot of debate around spaces and tabs, where some people prefer using spaces to indent, other people prefer tabs to indent, and there's a lot of people arguing in the coding community. And I think this excerpt from one of my favorite shows really demonstrates this.
Richard, what's wrong?
Nothing. Nothing. Literally, it's all good. Come on.
Oh my God.
I'm sorry.
Your roommates were right. You really hate spaces.
No. I don't. It's not hate. Hate's a strong word. Truth be told, I do have a slight preference for tabs, but that's only because I'm anal and because I prefer precision.
Well, not to pick a fight here, but if you really care about precision, wouldn't you use spaces? But whatever. Once it goes through the compiler, it's the same thing, right?
Yeah, technically, yes. I guess I just don't understand why anyone would use spaces over tabs. Like, if it's all the same, well, why not just use tabs?
Because it could look different on other people's computers.
Tabs create smaller file sizes, all right? I run a compression company. Trust me, I've devoted my life to minimalizing file sizes. It's what I do. I mean, I do not get why anyone would use spaces over tabs. I mean, why not just use Vim over Emacs?
I do use Vim over Emacs.
Oh, God help us. Okay, you know what? I don't think this is gonna work. I'm so sorry. I mean, like, what? We're gonna bring kids into this world with that over the heads? That's not really fair to them, don't you think?
Kids? We haven't even slept together.
And guess what? It's never gonna happen now because there's no way I'm gonna be with someone who uses spaces over tabs.
So should you be using spaces or should you be using tabs? The age-old question. And the extent to which people obsess over this question really shows in this 2017 Stack Overflow developer survey, where they asked the developers, do you use spaces or do you use tabs? And then they compared it against their annual salary and somehow have managed to show that the people who use spaces seem to earn a lot more than the people who use tabs. Now, the official guide from the Python community is in fact to use spaces. So if you click on this section, tabs or spaces, they tell you in no uncertain words that spaces are the preferred indentation method. And in fact, in Python 3, you can't mix a code file that uses tabs and spaces for indentation in the same file. And it also tells you that in order to indent a line of code, it should be indented using 4 spaces. So 4 hits of the spacebar. Now, for a lot of people, that may seem quite inefficient because I have to hit my spacebar 4 times in order to achieve a single indent. And you've seen how much we indent throughout our code. So it seems very, very inefficient. But luckily, in most code editors, they actually have a setting that allows you to indent using spaces, changing the indent size to 4. And when you hit the tab key, it will automatically insert 4 spaces, which you can tell when you're trying to highlight this space. You can see the cursor is jumping 4 times. This means that you get to hit tab once and that your code is in line with the guidance, because behind the scenes, your code editor is inserting 4 spaces. So I hope that clears up a little bit on tabs versus spaces, and I highly recommend you to head over to the course resources and click on the link to go to the style guide for Python code and take a look through the parts about indentation. Now, in the next lesson, I've got a quick quiz for you to test your knowledge on indentation. So for all of that and more, I'll see you on the next lesson. All right, guys, in this lesson, I want to talk about the while loop. The loop that will continue going while a particular condition is true. This is a really simple version of a robot that's using a while loop. So in this case, the instruction would be while you are plugged into the wall and you have electricity, move forwards. So this is what happens. It will stop once it pulls the socket out of the wall and it stops receiving electricity. Let's compare this against the for loop that we've seen before. So we've seen sort of two flavors of the for loop. One where we're looping through a list of items to do something with each item in the list. And the other is using a range function where we create a range between A and B, and then we use every number in that range to do something. For example, in this case, would be to print it out. The while loop looks something like this. And in this case, while this particular condition is true, then we go inside the loop and we do something repeatedly. And it's only when this something becomes false does the loop stop. So let's take a look at what the code would look like in real life. So here I have the hurdle 1 challenge that you did previously. And for this, we created a for loop in order to get our robot to jump over the hurdles 6 times to get to the final destination. Now we could also do the same thing but using a while loop. And this is how we would do it. Let's say we create a variable called number of hurdles, and we set that equal to 6 because there are 6 hurdles. And then we use a while loop to loop through these hurdles until this goes down to 0. So we could say while number of hurdles is greater than 0, colon, and then we get it to do something. Well, in this case, what we need it to do is to perform the jump function. And at the end of the loop, just before we go back to the beginning, we're going to decrease the number of hurdles by 1. So minus equal 1. So now let's go ahead and delete this version using the for loop. And in order to better visualize what's happening here, I'm actually also going to add a print statement to print that variable. So now let's step through this. And the first time we enter the while loop, number of hurdles equals 6, 6 is greater than 0, then that is a go ahead to jump into the loop and execute these 3 lines of code. So now we go in and it performs the jump function. And then once that's done, it comes back, goes on to the next line. Number of hurdles minus equals 1, so 6 should become 5. So now when it executes this print function, we should see 5 printed. So let's move this little pop-up away on the side and let's keep going. So now it's gone back to the beginning of the while loop and it's testing this condition once more. Is the number of hurdles, 5, still greater than 0? Well, so if it's true, then it goes into the while loop again and performs all of those lines of code. So now it's minus 1 and it should now be 4, and it keeps on going until the point where this condition, number of hurdles greater than 0, becomes false. So now this is the moment where we're going to subtract a further 1 from our number of hurdles, which is currently 1. So that should take it down to 0. And once that's done, this condition is no longer true. 0 is not greater than 0. 0 is equal to 0, but it's not greater. So now this is false, and we exit out of the while loop and we end our program. This is what the syntax for the while loop looks like. First, we have the while keyword. And then we have some sort of condition that we're going to test. So previously you saw it was number of hurdles being greater than 0. And whenever that condition is true, then it's going to look inside the while loop at the indented lines of code to carry out those instructions to do this, then do this, then do this. And finally, when it gets to the end of the while loop, it comes back to the beginning and tests this condition again. And if it's still true, then it's going to go through and loop and loop and loop until this condition becomes false, at which point it ends and exits the while loop. So now coming back to our Reborg's world, I want you to click on this drop down and go to hurdle number 2. Now, this is a little bit different, and if you want to see the explanation for this exercise, then simply just click on this world info and you'll see the explanation. So essentially, this hurdles race is a little bit different from the last one. Whereas last one, we knew that we had to always complete 6 hurdles to get to the goalpost. In this case, we no longer know where the flag is going to be. So it could be here, it could be here, it could be here, etc. And it's going to be set randomly to one of these positions. But what we now get is some sort of condition called at goal. And if this at goal is true, then it means our robot has landed on a flag. But if this at goal is not true, then it means that it's not yet reached the flag. So we can use our knowledge of while loops as well as this condition to use our code that we had from previously to get our robot to complete this hurdle race. So you should still have the code from the previous challenge up, and all you have to do is to think about how you would create a while loop so that when you run this program and the flag is set randomly, so this time it was set to be here, but the next time I run it, you can see it's now set here. It doesn't matter where the flag is, your robot should be able to detect if it's at a flag, if it's at the goal, and if it's not, then it should continue jumping. Pause the video quickly and see if you can complete this challenge, and then come back and we'll walk through the solution together. Alright, so the first things first, we know that we're going to need to use a while loop. And the condition that we're going to be testing for is this one, at goal. This condition can be true or it can be false. And basically, we're looking to see while at goal is not equal to true. So while our robot is not at the goal, then we want to perform the jump function. So we're going to jump for as many times as is required until this at goal becomes true. Another way of expressing this at goal is not true is to say while not at goal. So this is what they mean by the negation of this condition. Either way of testing this will work. And now if I hit run, you can see that even though we only need to perform one hurdle, as soon as our robot gets here and it checks that at goal is true, then it will stop this loop. But if our loop goes on for much longer, say the goal is over here, then once it reaches here and at goal is still false, then it's going to continue jumping until at goal becomes true. So that required a little bit of mental jujitsu, I think, because this entire condition has to be true, but this at goal is actually going to be false until the moment where we reach the goal. So by adding this not, we effectively flip this at goal. So if it was true, it becomes false. If it's false, it becomes true, in order to continue jumping while we're not at the goal. I prefer this particular type of syntax because it reads more like English. While not at goal, then perform jump. And if it is at goal, then it will stop. And one of the things you might be wondering right now is, so I've learned about the for loop and I've learned about a while loop, and if I can use both of them, why would I choose one over the other? When would I use a for loop and when would I use a while loop? Well, what I would tend to say is that for loops are really great when you want to iterate over something and you need to do something with each thing that you're iterating over. So, for example, if you're iterating through a list and you're saying for each fruit in our list of fruits, and you want to be able to say, I don't know, do something with each of these items in here. For instance, it can be as simple as just printing it. Well, then this will require for loop. You can't do this very easily using a while loop. Now, similarly, we've used the range function, right? So for range from 1 to 6, print each number in the range. Well, this, it's also easier to do with a for loop. Now, you want to be using a while loop when you don't really care what number in a sequence you're in, which item you're iterating through in a list, and you just simply want to carry out some sort of functionality many, many times until some sort of condition that you set. And this is also a good point to mention that while loops are a little bit more dangerous than for loops. Because in for loops, you're setting ahead of time how many times something is going to run. It's going to stop once it reaches the end of the list of items in this case, and it's going to stop once it reaches the upper bound of the range in this case. But for while loops, they will continue running until this particular condition switches to false. So if you have some sort of condition that actually never becomes false, well then your while loop becomes something known as an infinite loop. Because let's say that our while loop tested while 5 is greater than 3, then carry out these 3 lines of code. Well, 5 is always going to be larger than 3 until the end of time. And so that means your code is also going to run until the end of time, which is probably not what you want in most cases. If instead of saying while not at goal, I said while 5 is greater than 3, then you're going to see this robot perform this jump until eternity. And it's basically going to stop only once it's crashed and it's timed out. Now, every single programmer at some point in their lives will create an infinite loop. Don't worry about it, just quit the program, restart, and try to prevent this from happening in the future. And very often I find that it's really helpful when you don't know why you're getting an infinite loop to simply just print out your condition. So in this case, if I printed out 5 greater than 3, then it's always going to print true. And it's never going to become false, basically. In the next lesson, I've got more exercises coming up for you, namely hurdles 3 and 4. So head over there and put what you've learned about while loops into practice. All right, guys, it's time for yet another coding challenge. And this coding challenge is going to put into use what you've learned about while loops, while also testing some of the previous knowledge you got on functions. So I want you to head back to Reborg's world and change to hurdle number 3 and take a look at the premise for this particular race. Essentially, what's happened this time is that the wall placement has become random. So let's say we restart this game. You can see that in this case, there's a wall here, one here, one here, one here. There's 4 in total. But if we try a different version, then you can see that there is different wall placement each time. Not only do we know where the wall is going to be, we also don't know how many walls there will be. So code such as what we did before using a for loop telling our robot to jump 6 times is not going to work. And instead, we're going to have to use the conditions whether if front is clear, or whether if there's a wall in front, or whether if we're at the goal, and also their negations. So not front is clear, not wall in front, not at goal. See if you can use what you've learned about while loops, as well as your previous knowledge on if statements and functions to complete this challenge. When you have written the correct code, no matter what kind of wall situation or hurdle setup they have, it should always be able to get to the goal. And while I've been looking at this challenge, I know there is a very, very simple way of bypassing this challenge, which is simply to get the robot to go up here and all the way down here, going past all the hurdles. But that's not the point of the challenge. In order to complete this challenge, you must get your robot to follow the path that's set out in the dotted lines, instead of bypassing it and doing something completely different just to get to the final goal. Pause the video, have a think about this, have a read of the world info pop up here, and then think about how you can solve this challenge. So give it a go now. All right, so essentially, if we don't know where the walls are going to be, then we have to test to see if there is a wall in front or if there is no wall in front. And if there is a wall in front, then we're going to jump but if there's no wall in front, then we're just going to move forwards. And we're going to do this and test this for as long as we're not at the goal. So we're going to need a while loop that's very similar to our previous while loop that I showed you in the demo. While we're not at goal, or rather while this particular condition is not true, then we're going to repeat and loop some lines of code. The first thing we're going to do is we're going to use an if statement to check whether if there is a wall in front. So I'm going to say if wall in front. If this is true, then I'm going to perform the jump function and get it to jump over the wall. But if there is no wall in front, so namely else, well, in this case, we're simply just going to move forwards. And because our jump function is always going to get us to face the right way, which is this direction here towards the goal, then this move forwards by one function is always going to take us in this direction. So let's take a look at this code and let's step through it step by step. So the first thing we're going to check is, are we at the goal? At goal is going to be false, so not false is going to be true. So while this condition is true, we're going to carry out all the lines of code inside. So that means we should jump into this if statement and check, is there a wall in front? So at this point, this should be false because there is nothing in front. So it should bypass the if statement and it should go to the else statement, in which case it should move forward by one step. So that's the end of one loop, and we go back to the beginning. Are we at the goal yet? Nope, we are not. But now when we run into our if statement, this check should now come up as true because there is a wall right in front of our robot. So in this case, it's going to go into the if statement and perform the jump function.
Wow, wow, wow.
Now, our jump function that we defined previously actually gets us to move forwards by one step first before we actually hurdle over this wall. So in this case, if we try to do the same thing, then it's actually going to hit our robot into a wall. We have to modify our jump function by removing this first move function. So instead, we get it to just turn left, go up, turn right, turn right, go down, and then turn left to face the right direction. This is a pure hurdle without that extra step in the beginning. And instead, we're going to only move if there is no wall in front. So we've changed the code. Let's back it up and try this again with a different setup. And in this case, you can see as my code is going through the different steps, it's checking to see if there's a wall in front. If there is, then it's going to jump over it. If there isn't, it's just going to move forwards by one step, and then it's going to reevaluate. So this way, once it gets to here, it's actually going to reevaluate the while loop quite a few times, and every time it's going to be the else statement that fires. It's going to move, 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 move until it hits a wall again, and then it's going to jump over and take us to the finishing line. Did you manage to get this correct? Did you manage to get the solution right? If not, be sure to review the previous lessons on the while loop so that you familiarize yourself with it. And also, if you got stuck on changing the jump function, then be sure to remember that whenever you get stuck, it's important to test your assumptions. And in this case, you could have pressed the step through button many times to see which line of code is being triggered at which point and which is the moment where our code actually fails, so you can figure it out and fix it. Now, on the next lesson, I've got yet another code challenge for you, so head over there and give it a go.